and gentlemen, my name is Dušan Vukotić and came from DSO. This is the distribution system operator of EPS Distribucija. We are main distribution system operator. Before 2 years ago, we changed organization of all our utilities in Serbia, and we joined all these utilities in one common company. We call now DSO. This is based on a European regulative, and one of the main problem that we have in distribution on distribution level, what everybody talking about, this is a smart grids, and one of the part of this smart grids is integrated of distribution generator. This presentation is really part of our activities, what we have in the last few months ago, when we have very strong harmonization between our TSO. In Serbia also we have one TSO. This is SMEITS, one also public company. And based on the ETSOE initiative, this is an association of the transmission system operators in Europe. We have very strong activities on harmonization between the TSO and TSO, but one of the main points what we must harmonize is the integration of the DGs on electric network. Based on voltage level what we have in transmission network and distribution system, our boundary, our edge, it's on the 110 kV, and based on technical requirements and all these grid codes what we have in transmission and on distribution level, these edges, it's a little bit, strictly post there, and we have very clear technical regulative about it. But in the last period, in the last few years, we have very strong initiative to integrate DGs on the both side of this network, on transmission level, also on distribution level. Basically, on the transmission node and on transmission level, you have very large units, and this is a very power, sometimes several 100 megawatts. But on distribution level, we have huge bulk amount of the DGs. This is we have very small units, few kilowatts, but also we have large units. What more than 10, 20, 50 megawatts. What is the problem? What we have between the TSO and DSO? What is the ETSOE try to post one strict limits? What is the based on class D? What they call what is the installed power of DGs, what we connected on the transmission level or on the distribution level. They post these limits a little bit higher. I believe it's very high because it's put on the 75 megawatts. For us, from the distribution side, it's very high limits. And we try to reduce on the 10 megawatts. We have very strong reason what we want to promote these limits. It's when we look at in the others European countries, in Italy same limits, but in Denmark or Sweden it's a little bit higher, but less than this 75 megawatts what ETSOE promote. Basically, in this moment in Serbia we have more than, I believe, the less than 300 DGs what integrated on distribution system. And currently there is a big influence on our network. One of the big influence, because we have actually in this moment about 75 control centers on all distribution level what operated with our distribution network, and also we have very big amount of these DGs. We want to now to harmonize and regroup and reorganize this control center in the little bit small. We not yet define what is the final number of control centers what we want to have, but it's one of the problem because we will group also DGs and we will handle with not what is what is the situation in current period. Then we have per the one control centers maybe 2 or 3 DGs. Now when we group on the bigger control center, we will have more than 50 or 100 DGs what we must handle with these DGs. Based on this, we will also make some hierarchy of our control centers, and we decide maybe in the future, in the next 5 years, we will have only 2 types of our control centers. This is a distribution district control center and operational district sector, the control center, and edges will be on the 10 kV on the middle voltage, because when we define these edges between the TSO and DSO on 110 kV voltage level, we also make one strong edge on the 10 kV or 20 kV what we have in the distribution on the middle voltage distribution network. What is the edges between these control centers? Now also DSO and TSO have new rules in electric fields, and what is the problem what we have in the past period? We also have very good technical cooperation, but now this new distributed energy resources what we have in the network completely changed situation and relationship between TSO and DSO what we have currently in the network. And we actually have very full designation of distribution energy resources, but also on the other side you see, so then we have very strong initiative to centralize our operation over the network, and this is a really opposite directions, but also we have very strong influence of the market, and market is something, one factor we cannot avoid it in this moment, and in Serbia it's not very strong market like in Europe, but in the next 10 years we will have also this very strong market regulatives, and this is something what we must handle between them. Now you can see that we have more than relationships and more exchanging data between TSO, DSO, and independent producer of energy on our electric network, and this is something open very wide amount of the new services what we have in the future in our network. Also, one of the big problems what we have, and one what I want to make focus on this presentation, then initiatives, then you want to build up new DGs, like then you want to refurbish all the thermal plant, then you want to install new cogeneration units there. Then you have in this moment maybe 10 or 20 megawatts installed electrical power what you want to export to the electric network. It's no problem, then you have this plant far away from the substation, but if you have situation, then you have these plants very near the substation. It's open one question: when we connected these new sources on the transmission level, because on one substation we have this boundary, these edges between TSO and DSO, and what is the optimal position for the connection these DGs in this matter? If you have DGs far away from substation, it's obviously that you will connect it on the network. If you have what we have in one particle sample, then you have one thermal plant who is very near the substation, it's more than 1 kilometers. Then what is the point? Then we connect it on 110 kV on the TSO side or on the DSO side. This is something like bolt, and you put on one on the other side, and in the in real practice it's not easy, because everybody have own reason why we install on other side. Because if you have, actually when you have 20 megawatts or 10 megawatts, this is a small amount regarding the transmission company. But regarding the DSO, this is very huge power. And everybody have own reason, I mentioned. But finally, it's always decide to connect it on DSO side. For us, it's very big technical challenges. And this is something what we not really, and also in Europe, it's not covered this technical problem in this moment. But I expect in the next few years, maybe 2 years, we will solve it. And we defined all these scenarios, what we and how we integrated these DGs on our site. And what we have currently in the situation in the network, then we have problem of congestion. Next point. In Serbia, we connected, I've mentioned more than several hundred DGs. It's a very small amount of it. We have maybe this more than 10 or 20 megawatts, but we have a problem because what Maria mentioned on the first presentation, that we have very strong migration and migration to the town, and when we have some wind park generators, then we have very surplus of the production of energy, and we have condition, or what does it mean? It means that we re-export energy in the transmission network. This re-export of the energy, it means that we have actually technical losses, because we pay for this energy from the producers. Also, we pay all the fees for feed tariff for feeds for distribution transmission networks. And actually, this is our technical losses. And on the 7 point Serbia, we have problem because in some period of the day, then we have surplus of this production, and we must re-export transmission network. And this is based on contract between TSO and DSO. We don't cover this situation. Actually, this is one sample when you have like what they call virtual plant. Then this is a plant with negative injection. And this is something what we not solve it, because we actually our energy agency not cover with prices of connection this case, and in this moment we re-export energy. And this is one of the problem of the very best scenario planning, because we make a plan to development existing plan for developing network for the next 10 years. But suddenly some very huge DGs happens, and we connected maybe for the 2 years. We have a plan for the 10 years, and we always have these gaps between our plans and what we really have on the practice in the network. And this is the reason why we must reduce this planning period for the 5 years or maybe less. We reduce actually on the half all our plans. And this is the reason why we want to avoid this congestion. It's not easy to increase the loads. There is a lot of technical in optimization techniques in our fields on the DSO part, and we reconfiguring our network, but this is not easy. We have in some part of the Serbia very big migration to the capital, to Belgrade, to the north part, and we have our consumption going down. It's not easy to always have this balance between loads and productions. And this is some of the variants of the connection on middle voltage network, when you have several units or one unit, but it's only important what is really the point of the connection, and what is the really point when we want to connect these units on our network. There is a several scenario. All this scenario, it's some plans it's optimal, but we want to have what I put in this red box, red lines, it's really, then we have only one connection point, because on this one connection point we have one connection measure points, and it's very easy to identify exchange between generation units and our systems. What this is the one concept of integration DGs on 35 kV voltage level. Actually, what I mentioned, there is a these connection points could be on the network, on the black line, or they will be in our substation. The big misunderstanding between people who want to build up new DGs and us from the DSO, it's really what is the technical DGs facilities. Actually, DGs facilities, it's same like substation. There is a, have a base, then you have equipment, electrical equipment there, then you have block transformers, then you have generation unit. It's like transformer station, and but they always said, okay, this is not substation, this is a plant. But it's very hard to explain. There is really substations, and based on when you build up this plant and these facilities, you must have all this strictly regulation what we have for the substation. And it's mean then you must their RTUs, they must be integrated with SCADA system, they must be integrated with advanced metering infrastructure for the metering purpose. Then you have all this integrated system of the control and protection, but based on this, we always have some misunderstanding with there, and they won't always have some own plan. This is the reason why we actually defined these connection facilities, and this is the connection points when we connected DGs. Actually, when we have these lines between two substations, we cut off these lines, connected these DGs over this connection, not substation, but this is the connection facility. And based on this, over this red line, then you connect the DGs. Then you have a feeder base with measurement points, and you very easy to, but what I mentioned, we want to have only one. But when you have several DGs, it's not easy, then you have only one connection bay, you must have more than one. And then this is one typical scheme what present, but in the practice, this is a very complex scheme of the connection. It means that you have a lot of equipment, VTs, CTs, circuit breakers, disconnectors there, and also then you have connection, and then on the bottom side, then you have really just connection part of the connection of these DGs, and this is in the practice is very complex, and it means that sometimes, not sometimes, then you always must make some protocols between DSOs and these producers to regulate our relationship in the practice. This is something what in previous presentation, then you have very everybody talking about commissioning, about testing, but what is the big challenge? Then these plants must work the next 20-25 years, and this is a very huge period, and we must have very strictly regulative to how we handle between, and what is the really relationship between. This is not only contract between because on the low side you have a contract between us, like distribution system operator and producers, but must have a lot of these protocols regarding the technical matter what we must handle between. Then you have this, there is a very big problem about electric power quality, but also they supply, also what they receive from the network, what is the voltage profile, what we have in this connection points, and this is really a lot of connection technical problem. This is just I want to make a focus. Then it's not easy. Then you just build up DGs more than 10 or 20 megawatts and then just plug in connected with the network. There is a lot of technical possibility to connect these DGs on the network. One of them is optimal, but there is a lot of problems how we can handle. And we not have one magic stick to solve all these problems. And for each of these connections, we must make own studies. And based on these studies, we will finally make a final conclusion what is the optimal point of the connection to the DS source. And finally, conclusion. This is an existing mechanism should be able DGs to greatly adapt to output power based on real operating conditions on the network. It's no problem to handle all this, what producer what to export to our network, but this is another problem because we have very old network, and it's sometimes we must reform this network. This is our cost. This is not something what producer pay for over the interconnection fees, and the connection of the DGs of the large digital power currently getting importance because everybody who wants to build up new sources want to build up bigger sources. We have, I mentioned 200, but it's more than 80%. It's less than 1 megawatts. What is the edge? What our ministry make between when they divided on the large and the small DGs? But in the future, I believe then we will put this edge on 10 megavolts ampere for the installed power, and based on this edge, then we really divided what is a really connection scenario for DGs, even then they connected on the transmission system level or on distribution system level. Thank you.
Thank you.